Hello class, this is a video tutorial on prefixes and scientific notation. In the metric system, every unit of measurement has a base unit, and large or small versions of these are formed by adding a prefix. These multiply the base unit by some magnitude of 10. Magnitude of 10 meaning times 10 to the power of something. So here are a few prefixes that you might be familiar with. And as you can see, the base units is, like, for example, liters or meters. And a kilometer, we might make it capital K and M. Then we could get a megameter, a gigameter, and so on. Likewise, we can go smaller, meaning there are deciliters, centiliters. These ones aren't as common. Milliliters, microliters, and so on. So let's just take a look at how to work with these, mathematically. Here we go. So convert the following to their respective base units. Answer in scientific notation and regular notation. So here we go. 4.2, K is the prefix, and that is a kiloliter. So this means that the K is representing the multiplier as shown here. So a K is a multiplier of 10 to the power of 3. So this question becomes 4.2 times 10 to the power of 3. So this is the value in liters in scientific notation. And so writing this in regular notation, we simply move this 3 spaces across because it's 3. So 1, 2, 3, 4,200 liters. And there is our answer. As you can see, it's actually very straightforward. All you need to do is just be familiar with these prefixes. So this one is 8.05 gigagrams. So as you can see, a gigagram here is 10.9. So this will be 8.05 times 10 to the power of 9 grams. And now this is the answer in scientific notation. Notice how we're going back to the base unit that doesn't have a prefix. So from here, we just move this 9 spaces. So it's going to be 2 and then 7 more zeros. So 8, 0, 5, and then 7 more zeros. 1, 2, 3, 4, 5, 6, and 7. Putting commas every 3 just to make it easier. This is 8 billion and 50 million grams. I think I read that correctly, but as you can see, this is why we would opt for scientific notation. So let's move on with this one. 7.5 terameters. Terameters being T, it's 10 to the power of 12. So this will become 7.5 times 10 to the power of 12 meters. And so from here, I hope you can see now, it's just moving the decimal place that many spaces. So this would be 75 with 11 more zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And just putting commas on every lot of 3 to make it easier for us. I'm unsure what this actually is anymore. I believe it might be 7.5 trillion meters. I'm unsure what that is anymore, but that's how we would do this in both scientific and regular notation. So let's keep going with this time using smaller versions of these units. So 2.8, this one I'm actually not familiar with here. It's a microgram, so 2.8 micrograms. So it'll be 2.8 times, and the multiplier on the microgram is 10 to the power of negative 6 meters. So this is our answer in scientific notation. And then writing this in regular notation, just going to be 6 zeros in front of it. So 0, 1, 2, 3, 4, 5, 6, 2, 8 meters. That's a very, very small unit of measurement. Let's keep going here. 1.3. We know it's going to be times 10. And now ng is nanograms. So it's times 10 to the power of 9, negative 9, sorry, grams. And as before, this one's just going to be, it's going to be 9 zeros in front of it, including the decimal. So 1, 2, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 3 grams. You can always double check. So 9 spaces, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Good. And lastly, 4,000 milliliters. This one's something we're more familiar with. So this is going to be 4,000 times milliliters, 10 to the power of negative 3. As you can see, even this would work out, just moving the decimal place from here, and 3 spaces back. 1, 2, 3. 0.4 liters. And this actually confirms what we already know with these regular conversions. All right, so I hope that gave you an insight into prefixes and scientific notation. Hope to see you in the next video, and best of luck.